All right, guys, I know it breaks your heart when I say this, but this is the last one. This is the last college algebra lecture. I know you guys are just extremely brokenhearted, so let's get to it and finish up the material. Solving exponential equations. All right, so we're going to use in this lecture the inverse property between logarithms and exponentials. Okay, so what do I mean by that? Here we want to isolate the exponential expression. All right, we're going to take the either the common log on both sides, or we're going to do the natural log on both sides of the equation. So again, we're either going to use log base 10 or ln, the natural log. All right. We're going to simplify, using one of these properties. So if we have ln of b of x, then, we're going to write that as x ln b. Ln ex, the ln and e undo each other. And then similarly, if we have log base 10 of 10 to the x, then of course the log base 10 and the 10 undo each other. Okay. And then lastly, we'll solve for a variable. All right, so let's get to some exponential equations. We have 5 raised to the x equals 134. Okay, how are we going to go about solving this? Well, I'm going to say let's ln each side, or use the natural log on each side. So I apply the natural log to both sides. All right, can I rewrite ln 5 raised to the x? Yes, I can. I can use the power property, all right, and bring that x out in front as a coefficient. So I have x times ln of 5 equals ln of 134. I can solve for x by dividing both sides by ln of 5. All right, you guys, this is what's called the exact solution. All right, so be careful with the wording in my math lab. The exact solution is ln of 134 divided by ln of 5. The approximate solution is when we plug it in our calculator and get 3.04. All right, so it depends on how my math lab asks as to what you're going to type in the homework. For me, on the exam, I would take either answer. All right, and so the exact solution set is ln of 134 divided by ln of 5. All right, what about 10 raised to the x equals 8,000? Well, here we want to use the common log on both sides, since we have an exponent with base 10 in our original problem. So I apply the common log to both sides. All right, on the left side, log base 10 with an exponent of base 10 are going to undo each other, so they just kind of cancel out, so to speak. And so we have x equals log of 8,000. All right, log of 8,000 is our exact answer. If we type it in our calculator, we're going to get approximately 3.90, which is considered the approximate solution. All right, so the exact solution set is log of 8,000. All right, here's a new one. We have 3 raised to the 2x minus 1 equals 7 raised to the x plus 1. What do you think we're going to do? Well, let's ln both sides. Remember, our only option is to use natural log or the common log. So I'm going to use the natural log on both sides. Well, how does this help me? It helps me because it's going to bring that exponent, what's in the power, the 2x minus 1 and the x plus 1, out in front. All right, be sure to use parentheses here. All right, we've got 2 terms each. So now that I have used the power property, I have in parentheses 2x minus 1 times the natural log of 3 equals, in parentheses, x plus 1 times the natural log of 7. All right, I need to distribute on both sides so as to get rid of parentheses. So I have 2x times natural log of 3 minus natural log of 3 equals x times the natural log of 7 plus the natural log of 7. Well, I see here that x is only ever to the first power. That means it's linear in x. So let's get all of our x terms on one side. All right, I subtract x times ln of 7, all right, and I'm going to add ln of 3. All right, so I get my x terms on one side, I get all non-x terms on the other. All right, on the left side, What I want to do here, since I have two terms each with an x, is I want to factor that x out. You guys often refer to this as reverse FOIL. So I pull the x out of each term, leaving me in parentheses with 2 ln of 3 minus ln of 7. Now I can get that x by itself by dividing both sides by those parentheses. And so my exact answer is x equals ln of 3 plus ln of 7, all divided by 2 ln of 3 minus ln of 7. All right, our exact solution. Well, if I plug all that in my calculator, I'll get my approximate solution as 12.11. All right, so hopefully you understand how to use the ln on both sides to get those exponents to drop down as coefficients, and hopefully you can distinguish between the exact solution. All right, now let's do a few applications. All right, so let's consider exponential growth when it comes to money. How long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? Well, let's go back to our compound interest formula. All right, what do we know? Plug in what we know. We know that A, the money we're growing to, is $3,600. We know P, the money we put down, is $1,000. And we know our interest rate is 0.08. And since we're compounded quarterly, N is going to be 4. We need to solve for T. Okay, so what's the first thing we're going to do? Please excuse my dear Aunt Sally, right? So let's simplify inside the parentheses first. 0.08 divided by 4 is 0.02. Now let's add the 1 and the 0.02. All right, so we simplified inside the parentheses. Now we want to divide both sides by 1,000. Let's get that exponent, the 1.02 raised to the 4t, by itself. So we divide each side by 1,000. Now, how do we get that? How are we going to get to that t? Well, let's ln both sides. Remember, by applying the natural log to both sides, that enables us to use the power property so we can bring that 4t down in front of the natural log. All right, so now we can go about solving for t, and we can divide both sides by 4 and ln of 1.02. This is our exact solution, but this certainly doesn't make sense to us in terms of a year, does it? If you asked me how long will it take you to take the exam, and I said, have no fear, it'll be ln of 3.6 divided by 4 times ln of 1.02. What the heck does that mean? Let's talk time in the way we understand it. So we plug this in our calculator and get approximately 16.2. And so after approximately 16.2 years, $1,000 will grow to an accumulated value of $3,600. All right, let's do another word problem. The percentage of adult height attained by a girl who is X years old can be modeled by this purple function, 62 plus 35 log base 10 of x minus 4, where x represents the girl's age from 5 to 15, and f of x represents the percentage of her adult height. At what age, so we're going to solve for an x, at what age has a girl attained 97% of her adult height? All right, well, 97 is the f of x. We need to solve for x. How are we going to do that? Well, the first step is going to be to subtract 62 from both sides. Now we want to get that log by itself, so we'll divide both sides by 35. So I have 1 equals log base 10 of x minus 4. How might I undo log base 10? What's the inverse of log base 10? It's an exponent, right? With 10 as the base. So let's apply the base 10 exponent to both sides, undoing the log. So I have 10 equals x minus 4. We can easily solve for x here by adding 4 to both sides, getting 14. At approximately age 14, a girl has attained 97% of her adult